So in this lecture, you are going to see the notification on my showing up on my monitor really often, like asking me to update my Windows license. I just called IT since this was purchased from the college. I'm gonna go there to update it after this class. Sorry for that. So if you look at the schedule, so the traditional lectures are pretty much done. So the first couple weeks from today and the next 1 week and a half, 1.5 weeks, you are going to work on homework 3. If you click homework 3, what's the due date for homework 3? September 25th. So pretty much 2 weeks from now. So there are a couple issues you need to figure out, which can be used for the balanced car project as well, and also the robot arm project. So it's like laying the groundwork for these 2 projects, some practice. And the first one is just calculation. You are going to just hand over a hard copy to me on the due date. And for the other ones, you need to do a demonstration. So on the 25th, which is Friday, in the 5th week, I will have a spreadsheet. So if you finish this one, I'm going to check that for you. Right? 20 points, 20 points. Let's take a look. What are they? The first one is pretty simple. You need to program the protocol by yourself instead of using the SR04.h library. And I think I mentioned this during one of the slides lectures. You can download the slides, I think, from where? I think I uploaded. Oh yeah, here, right? I have example code in one of the slides. Just go to there and find out that code. Try if that works. Okay. If that doesn't work, probably you need to reprogram your setup function or something. See if you can find out some solutions online as well. Just trying to debug your script and make it work. That's the second one. So the third one is trying to recall your memory. I think so most of you were in a junior design class in the spring. So you worked with MPU 6050, which is going to be the main sensor for your balanced car. And how to access to the registers, how to do the configurations to the registers. You need to practice on that a little bit. So throughout this homework assignment, you will be able to know how to use it. So you won't be an expert on that, but you will recall your memory about how to use it. Okay. If you are new to this sensor, which is fine, since I have a website, have a tutorial, have all the details about how to use it over there. I even have some existing examples you can directly copy and paste. Just need to have the correct hardware connection and upload the code to your Arduino board. It should be able to work pretty quickly. You need to modify the code a little bit after the Arduino microcontroller received all these signals. Just add a little bit if statement in there or loop to make a judgment about the signal intensity is being received. So you want to set up a threshold. Whenever the vibration level is higher than that threshold, just trigger the buzzer. Okay. I have a buzzer here. I'm going to give it to you after the introduction. And how do you program the buzzer? It's over here. Download this package. So the Arduino box you have, they have a CD disk, but we don't have a CD-ROM on your laptop probably. So download this package. It has a PDF instruction for every single experiment with all the sensors in the box, plus the Arduino sketch. So there's a folder called code. So that folder has all the sketches examples in there. you can directly use. They're ready to use actually, and they have libraries. So probably if you do not have the libraries loaded in your Arduino IDE, you probably want to copy and paste that library to your Arduino's folder in your desktop or laptop to make it work. So use this package for 304 you're going to work on. How to make the buzzer work? I think they have example code in the folder. So download the package. Okay. For the last one, you'll need a stepper motor, and you need a driver for the stepper motor, and you need a battery to power it up, and the battery should be 12.5 volts. So, have you ever heard about Lipo battery? Lipo. So these batteries, so something like this, it has more than one cell. I don't know why they define every cell to be 3.7 volts. Let's take a look. So if you buy a battery like this, and you can see that the 14.8 volts is being checked. Okay, and for the standard, it's 3.7 volts per cell. So how many Lipo cells in this package? How many Lipo cells? So apparently they put the batteries in series or in parallel? In series. So the voltages are adding up. And how many cells? 4 cells. If they check the 11.1 volts, how many cells are there? 3. Okay. And if it's 7.44 volts, it's going to be 2 cell. It's a 2-cell Lipo battery. Okay, so that's a standard how you do analysis, how you know what's going on here. The reason you need to know that, definitely, if you have more cells, it's going to provide more power, more current, more voltage, right? And also, when you are charging up a Lipo battery like this, a multi-cell Lipo battery like this, you need a specific, you need a dedicated charger for it. And when you are setting up the parameters in the charger, you have to tell the charger how many cells are there for the battery and what's the current. So for this one, it's 450, it's 4,500 milliamp hour. So you need to set up the charger with the correct current. So that's what you need to know. That's pretty annoying because you have to buy a specific charger just for charging all these batteries. And for the chargers which can charge up a couple of batteries at the same time, it's pretty expensive. And for the affordable ones, it is unable to charge one battery at one time. So it's annoying. I have purchased a lot of Lipo batteries like this. They are 3-cell Lipo batteries, which is 11.1 volts. It's good enough for power up the balanced car, I think. But because if you look at the connector, I do ordered all these adapters for the connectors like this. See that, something like that. So the cable is pretty thick because the current is high. It's normally running a couple of amps. For example, the 4500, it's 4.5 amp, right? So need a thicker cable to handle that current. And the connector, you can see it's a little bit special. Probably is for the high current as well. So what I'm thinking is I have a different option, so which is a battery cartridge instead of this one. So the battery cartridge can have 3 Lipo batteries, but looks different from this one. I want you guys to try that one first. As long as that one works, can provide enough current for your stepper motor, use that one. Because this one have to design a connector, for this, and I only have a one charger for all of you guys, so can be a little bit challenging. But feel free to use this one as well. It's just a little bit challenging. We don't have too many chargers to support that. So you need a battery, you need a stepper motor, and what I'm saying here is you can use HC05 Bluetooth module. So on Wednesday, I think I gave you another wireless module. That one is the Dutch person who invented the balanced car in the video I showed to you. He used exactly the same Wi-Fi the wireless module. So the benefit to use that one is they have the code already working for his car, so you can probably directly copy and paste. And but that module and this module they have the same wavelengths. These are both on the 2.4 gigahertz, and wirelessly it's the same frequency, and the hardware connection are both UART, which is RX and TX. So I really don't know what's the main difference between these two modules. If the one I gave to you doesn't work, then you can switch to this one and try it. Okay. So in the following 2 weeks, probably you are going to expect working here or in 602. So my 602 lab is just pretty close to here. That lab can only, the capacity over there right now for during the pandemic is only 5, I guess, 405. So probably 2 or 3 of you guys have to work here with a computer. If you need a power supply, you can go there and connect to the power supply, and after that you have to leave. We couldn't have 7 people in there at the same time, but it's pretty close by, so I don't think there's any significant difference. We'll see. If that's super inconvenient, I can open up another lab close to Gabe's office. There's another robotics lab. We can use that one as well. If that's necessary, okay, I can open that one for you. You can start working on this one. I think this one as well, since you have the ultrasonic module right in your box. And this one I have a buzzer. I can give it to you now, so you can work on. If you are willing to work in the weekend, so you can work on this one. But for this one, let me see. Since I don't have the battery and cartridge right now, probably I can grab it now. And when you are working on the first 3 ones now, I can bring them over. So I have some larger boxes, so you can keep one of these and put your kit into the larger box and all the other parts in there as well. Okay, let's do that. Okay, so I'm gonna bring over the NIMOS stepper motor, the driver, the battery, and the HC05 Bluetooth module. If you want to look for some of the HC05 Bluetooth modules code, you can also find example from the Allegos package, which is here, because that module came from this box, this kit. So it has an example. Any questions? Okay, so this is a little bit different from the other tutorials in 315 in junior design. I have all the examples, all the code provided. So this is a little bit open project. But I have all the resources available for you, so you can check out all these examples and combine them together. Steal this piece of code from different places and put them together and make it work. Okay, so let's start working on that.